Okay, student. Today we will see mathematics for grade 7 Ethiopian for Ethiopian students. Har'a kan ilaallu mata duree herrega kutaa torbaffaa waliin ilaallaa jechuudha. Innis boqonnaa tokko eegala. We will start from chapter 1. Chapter 1 starts at rational number. What is rational number? Students, as mentioned on the outline, after completing this chapter or this unit, students should be able to define and represent rational number. Rational number. You should be represented rational numbers, and you should be give the definitions of rational numbers. Second, show the relationship between among whole number, integer number, and rational numbers. Order rational number. Perform operations with rational number. Those operations are maybe addition, subtraction, multiplications, and divisions. So you should be operate those operations also. As introduction in the previous grade, you had already learned about fraction and decimal numbers in grade 5 and grade 6. These numbers together with integer form a bigger set of numbers known as a set of rational numbers. Set of rational numbers. In this unit, you will learn about rational number and their basic properties. You will also learn how to perform the four fundamental operations like multiplication, addition, subtractions, and divisions on rational number. We will see one by one detailing. The concepts of rational number. Students, what is the concepts of rational number? I hope you learn some concepts of rational numbers on mathematics for grade 5 and for grade 6. But later we will talk on these topics. Drop work, discuss with your friends, with your friends. The student is near to you, like from this Venn diagram you are define a lot of definitions for rational number, natural number, whole number, and integer numbers. The Venn diagram below shows the relationship between the set of natural number, this number, whole number, the second circles, and integer number or the largest and third circles. Define a set of natural number. What is natural number? Natural number starting from positive 1, positive 1, 2, 3, 4, 200. Those numbers are known as natural number. Natural number. So on the second, you should talk about whole number and integer numbers. So the natural number is a set of subsets of whole numbers, and whole numbers are subsets of integer numbers, as you see from these Venn diagrams, which means that the integer numbers are consists of whole numbers and natural number. Give some examples or 4 or 6 examples of natural numbers. So in here we will see natural numbers like you can give as example starting from 1 up to 6 or 10 up to 12, 10 up to 16, 20 up to 26 or 100 to 106. You can give positive the positive parts of integer numbers, known as natural number. As example, the third one is give an examples of whole numbers. Whole numbers. These whole numbers starts from 0 in addition to natural numbers. You can give 0 to 5, or you can give 0, 1, 2, 3, 4, 5, or you can give 101, 102, 103, 104, 105, and 6. The fourth one is name 6 positive integers. Here, the positive integers means starting from number 1, or the number before zeros, before zeros in the right sides of the in zeros. You can give name 6 negative integers means starting from negative sections or the left sides of the zeros on the rational number graphs. On number 6, to each sets of natural, to each sets of numbers does each of the following numbers belongs. 0 shows that whole number. 25, that is included, you can say, as whole number, natural number, and a positive integer number, you can say. Negative 102, this one is what? Negative integer or integer number, negative sides of integer number. D 30 over 12, you can minimize, you can talk as set of rational number or set of rational number. Put less than or greater than instead of the box below. Each part of numbers give below to make it true. So negative 10 is 76 means negative integer dash 6100 means less than. We should negative 76 is less than 600. Negative 1200 dash negative 800. So negative 1200 is less than negative 800, because as the negative side means more depth. So this one is less than. We use negative 800, it greater than negative 1200. 0, negative 10,000. 0 is greater than negative 10,000. 111 are revisions on integer numbers. In grade 5 and 6 mathematics lessons, you have learned several facts about set of natural number represented by capital N, whole number represented by capital W, and integer numbers represented by capital Z. In each these subsections, you will revise some important facts about set of integers. Discuss with your friends or partners. Please discuss by group or before now seeing the answers. You should be analyzed by yourself. Question number 1. For each of the following statements, write true if the statement is correct. Otherwise, say false. Or if the statement is not correct, you say false. Hint: union these intersection symbols you learn in grade 6. A. The sets plus 0, 2, 1, 2, 3 up to infinite describe the sets of natural number. This one is not natural number, the set of whole numbers due to 0. So this syntax or this equation is false. B. The sets negative infinity 2, negative 2, negative 1, 0, 1 to 2 describes the set of integer numbers. Yes, that's correct. Set of integer numbers. The answer is true. C. Natural number union with whole number equal to this. Yes, this set is the set of whole number. So, natural number is a subset of whole number. This union of natural number with whole number is by itself whole number. So, it is true. D. Natural number intersect with the intersections of natural number with integer number is by itself a natural number, because natural number is a subset of integer numbers. Integer number is a combination of natural number and whole number. So the positive side 1, 2, 3, 4 to infinity is the intersections of those is by itself integer number. It is true. 126 is a natural number. Yeah, that's correct. Natural number. It is true. To the next sections. Question number 2. Is every natural number a whole number? This question. Say yes or no, or say true or false. Is every natural number a whole natural number? A whole number? Yes, natural number is a subset of whole number, but every whole number is not natural number, except due to 0. It is, if it is so, you can say natural number is a subset of whole number. Yes, it is true. Is every natural number an integer? Yes, every natural numbers are the positive integer number. It is true, which means natural number is a subset of integer numbers. Is every whole number an integer number? Yes, it is subset of natural whole number is subset of integer numbers. So whole number starts from 0 to positive infinity. So the right side of the integer number is known as whole number. Note the sets of numbers consisting of whole number and integer number is called the set of integer, which means that the combinations of whole number and negative integer number is totally the sections of integer number. Set of integer number. The set of integer number is a combinations of all whole number plus the negative numbers of integers, which means that integer number denoted by z, the subset, the set of negative infinity to negative 3, negative 2, negative 1, 0. This section is the sections of whole number starting from 0 to infinity is whole number. So whole number plus negative means this side, this side. So from this graph, number line graph, easily you can understand. Starting from 0 to the right of the zeros, the set of whole number plus the left of 0 is negative integers. So this line shows that totally integer numbers, the set of integer numbers was the combinations of negative integer, 0 and positive integers. In other words, integer number is the combinations of negative integers plus the whole number. In other words, integer number is the combinations of negative integer plus 0 plus natural number. From these sections we will see some definitions of temperatures. I hope that temperature is the degrees of hotness or coldness of some objects. So the instrument used to measuring temperature is known as thermometers. This is a physics word. If the temperature or the measure of temperature is less than 0, it is negative. Negative. If the measured values greater than 0, it is positive. in temperature. Language, we can say. So from these thermometers, the negative sections are below negative 0 means negative sections. The positive section means above 0 reading. From this thermometer reading, you can easily understand this, which means if you see section number A, 75 above 0 means 75 above 0 means the number greater than 0 around here. 70, 75 around here. This one is positive sections. Positive section means the temperature is greater than 0. That's positive 75. 40 below 0 means 40. This 0 here. 40 means in here 6 section or this section you can take. Means below means the below means the major temperature is less than 0 means very cold. It's negative 40. So below and above degree centigrade temperature means to show hotness and coldness. Cold means less than 0, hot means above 0. As this shows that when we write in a number and words, the answers of the above sections. From grade 5 and 6 mathematics lesson, radical. Recall that. Again, this one is repetition. The set of natural number denoted by n, capital N, described by natural number. Write in this word, write in this symbols. Natural numbers equal to the set of 1, 2, 3, infinite. The set of whole number denoted by capital W, capital W. This one is the set of whole number, the set of natural number. The set of integer means the combinations of natural number plus whole number. In other words, integer means set of integer means equal to the union of natural numbers and whole number. As the sum of two natural number, always natural number. If you are adding natural number, all natural number, you get natural number. The product of two natural number is always natural number. If you multiplying natural number by itself by natural number, you can get natural number only. The difference and quotient of two natural numbers are not always natural number. Sometimes you get natural numbers, but it is not always, because if you subtract number 2 from 1, you get negative. Negative 1 means not natural number. As example, negative 1 is not natural number. It is integer number. So it is fault, not always. If you subtract 1 from 2, you get 1. In here you get natural number. So the word all is not correct. Not all. Sometimes you can get, but sometimes the rule is broken. The sum of two whole numbers is always whole number. Yeah, if you are adding whole number, you get whole number. The product of two whole number is always whole number. That is correct rule. The difference and quotients of this one also not. Sometimes you can get, sometimes not all, but sometimes we can get. If the quotients, sometimes that's true. The sum of two integer is always integer number. The product of two integer numbers is always integer numbers. The difference of two integer numbers is always integers. The quotient of two integer numbers is not always an integer numbers. You can get in here rational numbers. The concept of rational number is come from here. Okay. The fourth rule is not always, sometimes. Revisions of fractions. I hope you learn daily in grade 5 and 6 mathematics lessons. Herrega kutaa 5 keessatti barannoo herregaa kutaa 5 keessatti fraactionii maal akka ta'e gad fageenyaan barattanii jirtu. Daily you learn the definitions of fraction, but as revisions we will see learn about definitions of fraction, operation on fraction, and types of fractions. Recall the following. Operation means ideu hir'isuu hiruu baay'isuun 4 operations: multiplication, subtraction, division, and addition. We will see types of fractions. gosoota fractionis ni beektu. Fractionii sirrii fi fractionii sirrii hin taane jedhamuun qoodamu. Types of fraction when we say. So note, fractions are numbers of the form or the number written in the form of a over b or c over d or n over m, where a over b equal to a divided by b when a and b are a whole number, in a whole number, and b is not equal to 0, whole number starting from 0, but always b is different from 0. A, instead of a we can use 0, but instead of b we can't, because undefined. If b equal to 0, this fraction is known as undefined fraction. Fraction hiika dhabeessa jedhamee waan beekamuuf a over b jennee fraction moggaasuu dandeenya. As keessatti a'n 0 ta'uu danda'a, whole numberii abba barbaade, garuu b'n 0 ta'uu hin danda'u, hiika dhaba waan ta'eef. We can represent a by any whole number except b. B is different from 0. In the fraction form a over b, we can say a numerator, b denominator. A over b means fraction a numerator, b is denominator jedhamuun beekamu. Kana jechuun waamamaa fi waamsisaa jechuudha. Numerator waamamaa, waamsisaa jechuun beekamu. Afaan Oromootiin waamamaa jala waamsisaa isa jennu sana denominators over numerators over denominators jennee waamnaa jechuudha. Examples of fraction in figure 1.5 below. Fakkeenya fractionootaa. This football pitch has two halves, which means that these sections and these sections. Kana jechuun dirreen kubbaa miilaa tokko sectionii lama qaba. Section B fi section B jechuudha. A fi B jechuudha. Faallaasaa kan taphatanii fi gara faallaa kan taphatamu. Kanaafuu sararri kun half sectionidha. This line is known as half sections. One part is 1/2 or 1/2 of the pitch. Total pitch, half of pitch, half of pitch. In here, this DVD has 8 equal sectors. DVD'n kun seektaroota 8 wal qixaa qaba. Seektaroota jechuun isaan kana lakkoofneeti jechuudha. Sectionoota kana yookaan qoqqoodamoota kana lakkoofnaa jechuudha. The shaded part is 7/8 of the DVD, which means section part means 1, 2, 3, 4, 5, 6, 7. Totally 8. This white color is not shaded. Halluu adii kan qabu hin dibamne. Kanaafuu halluuleen dibaman torba, sectionoota torba except one, which means 7/8 are shaded. 7/8 are shaded. One hand is left, which means that 1/8. If we are sum 7/8 plus 1/8, we can get one full section or one full DVDs. 8/8 equal to 1. This chessboard has 64 equal small squares, which means that you can count this small square, red and white. You can get 64. From that, one part is 1/64. 1/64 of the chessboard, which means that these sections are 1/64, or these white sections are 1/64, or you can write as, if you take 2/64, white plus red. So fraction means the section or the divisions of one thing. Example is let 2/5 or 2/5 of the parking spaces be occupied. Then find the numerator and denominator, which means that once parking 2, 3, 4, 5, these are a parking. Parking ka jennu bakka konkolaatonni dhaabatan kana, sekshinii konkolaatonni dhaabatan kana shantu jira jechuudha. Sekshinoota shanan keessaa lama qabamaniiru konkolaataa kanaa fi kanan waan qabamaniif shanan keessaa tokko lammaffaan lama shanaffaan qabameera jennee ibsinaa jechuudha. From those 5 sections, 2 are occupied, which means that 2/5 are occupied, which means that 2 numerator, 5 is denominator. So 2/5 solutions, the top number is called what? numerator. The bottom number is what we call denominators. Waamaman waamsisa. Based on the numerator and denominator, you can classify a given fraction into two. These are proper functions and improper functions. Types of function based on numerator and denominators, which means that in afaan oromoo waama waamsa irratti hundoofne fraction bakka lamatti qoodna. Fraction sirrii fi fraction sirrii hin taane jedhamuun beekamu. Fraction sirrii ka jennu yeroo waamamaan waamsaa inni gubbaan waamaan inni gubbaan waamsisaa gadi ta'edha. Qixa taanan fraction sirrii hin taane jennee waamna. Fraction sirrii hin taane jechuun waamamaan waamsisaa caale gaafa dhufe. Kana jechuun when we call proper fractions, proper fraction means the values of denominator is greater than the values of numerator is less than the values of denominators. In proper fractions, the values of numerator greater than the values of denominators. If the numerators of a fraction is less than denominator, then the fraction is known as proper fraction. That is, a over b is called proper fraction means if a is less than b. This one is proper fraction. In oppositely, if a greater than or equal to b, we call improper fraction. Improper fraction. If the numerators of the fraction is greater than or equal to the denominator, then the fraction is an improper fractions. That is, fraction a over b is called improper fractions if a is greater than or equal to b. If the proper fraction is expressed, proper fractions are expressed as a whole number and proper fractions, then it is called mixed number, which means that when we are writing the fractions with proper fractions in addition to whole number, this fraction is known as mixed number, discussed with your teachers orally. Here, name the numerators and the denominators of each fractions. 5 over 6. 5 is less than 6, which means that numerator is less than denominator, what we call proper fraction. This one is 12 over 10. Numerator is greater than denominator, so improper fractions. 3, 2 over 5, which means mixed fraction. Mixed. This one is proper fraction with whole number. So this is called known as mixed fraction. Mixed. A over b, where b is different from 0. This one is fraction, normal fraction. Give examples of your own for proper fractions and improper fractions and mixed fractions. You can take as proper fraction 1 over 2, 5 over 10, 10 over 100. Such like fractions are known as proper fraction. Improper fraction means like 13 over 10, 20 over 5, 100 over 1000 or 100 over 10,000. You can say as improper fractions. As for mixed fractions, 10, 2 over 3, 5, 1 over 3, 5, 1 over 10, you can say as any number. Change those improper fractions. Those one is improper fraction because numerator is greater than denominators. 2. Mixed numbers. This one is exercise. You should be change or calculate the given one, the given improper fraction into mixed fractions. When we write 5 over 2, we call easily 5 divided by 2, 2, 1 is left, so 2, 1 over 2. This one is 9 full of 3 over 4. This one is 2, 8 over 9. we can write as this one is 1 full 7 over 10. We can change this mixed fraction into improper fraction into mixed fraction, mixed number. Change this one into improper fractions. So 4 times 3, 12 plus 1, 1 3 over 4. This one is 4 times 5, 20 plus 2, 22 over 5. This one is 10 times 3, 30 plus 7, 37 plus 10. 100 times 1, 100 plus 9, 109 over 100 when we convert this mixed number into improper fraction. 1.13 revisions on equation fraction. The revisions of this. Discuss with your teachers on orally. Copy and complete each of set of equivalent fractions. Equivalent fraction means the fractions which are written in different forms but their values are equal. On number A, the given fractions are 3 over 4 equal to the denominator is given, the numerators of the fractions not given. So we can simply multiply by cross 3 times 8 equal to 4x. So 24 over 4 equal to x means the values of this here is 6. So 3 over 4 equal to 6 over 8. 3 over 4 equal to 3 over 8. And 3 over 4 equal to 6 over 8. In here, you can directly calculate from here or based on the variations between 3 to 6 is 3. So 9 over 12. The increment is increased by what? The increments of the numerators increased by 3. So 9 plus 3, 12. 12 plus 3, 1, 5. 12 plus 3. 12 plus 3, 1, 5. 1, 5 over 20. 12 over 1, 6. No. Yeah, 12. 1, 5 over 20. This one is 1, 8 over 24. On number B, 2 over 7 equal to what? Dash numerator over 1, 4. So 12 times 2 times 1, 4 equal to 7x. 28 equal to 7x means the result is 4. So 2 over 7 equal to 4 over 1, 4. Here is, you can calculate directly from that. 6 over 21, 8 over 28, 10 over 35. This one is 12 over 42. The increment is increased by 4. Increased by 2, 4, 6, 8, 10, 12. The increment is increased by 2. C 4 over 5 equal to x over 10, which means that 40 cross 4 times 10 equal to 5x means the x equal to 8. We can get easily by using cross. 8, 12, 1, 6, 20, 24 is the answer. Consider the given fractions 6 over 8, 12 over 1, 6, 24 over 32, 48 over 64 are the equivalent fractions, which means if you are simplification by using the rule of simplifications, you can get 6 over 8 or 3 over 4. You can minimize this result also. An interesting properties of a rational number is that infinitely many different fractions may be used to represent the same rational number in figure below. So these line numbers are showing the simplifications of, which means 0 means 0 over 2, 3 1 over 3 means 1 over 3 indirectly, or 2 over 6, or you can, this shows that the simplifications of these numbers, these ones, the simplifications of those numbers, these ones, you can simplify, or you can write in any forms, but the values are the same, their values are the same, the point or the representations of the point from the line number is at the same point. If you take 4/8 equal with 1/2, which means that by 4/1, by 4/2, 1/2, the result are the same when you're representing on the line number. 1/5 means 0.5 equal to 4/8. So this one is similar. The simplifications are the same on line number. From the above figure 1.7, we get this one, so the above example graph, this graph. 0/2 equal to 1/0/100, 0/90, 900, 0/7000. They are equal to 0 completely. We write in different terms. This result is equal to 0. Equivalent. Those fraction is known as totally equivalent fraction. Equivalent fractions. The equivalent fractions are written in different forms. So you can easily see 1/2 equal to 2/4 equal to 4/8 equal to 8/16 equal to 1/2. These fractions are equivalent fractions. Equivalent fractions. We can write in different forms for different numbers. Therefore, using the above discussions, we define equivalent fractions as following definitions of equivalent fractions. The fractions that represent the same point on number line on the number line are called equivalent fractions, but the reading and writing forms are different. But when we are representing on the line number, they are represented on the same point, which means that their values are equal. This fraction is known as equivalent fractions. Equivalent fractions. Example: you can see this one is equivalent fractions. 3/9 equal to 3/3 times 1/3. 9/27 equal to 9 times 3/9 times 3. 9 times 1 times 9 times 3. This one is their equivalent fractions. Equivalent fraction represented on the same line of number. Equivalent fraction ka jennu fractionii wal qixaate. Fractioniin kun sarara lakkoofsa irratti gaafa ka'u gatiin isaanii tokkichadha. Garuu bifa adda addaatiin value denominator fi numerator sun gargar ta'ee gaafa argamu jechuudha. Kanaafuu represent gochuu dandeenya jechuudha. Furthermore, the above example 4 can be generalized by the fundamental properties of the fractions as follow. Fundamental properties of fractions, basic properties of fractions. For any fractions A over B, if m is number, if m is any number other than 0, A over B equal to m over m. M over m means 1. But therefore A over B and A over B times m over m are equivalent fractions. Equivalent fractions. The values are not different, but the arrangement or rewriting of the object is different. Two fractions A over B equal to C over D, BD different from 0. Always the denominators of the fraction is different from 0. Then AD equal to BC. In equivalent fractions, the critical of the result from what we get from the fractions are equal. Look at the following examples for very carefully. Show that 6/5 and 1/5/1/8 are equivalent fractions. Easily you can minimize by 3, 5/3, 6, they are equivalent fractions. Or you can multiply 5/6 equal to 1/5/1/8. Then we get 90 equal to 90. These fractions are known as equivalent fractions. Rational number. This number is known as rational number. In integer numbers, there is no fraction. In rational number, including all integer numbers with a fraction number. The difference between rational numbers and integer numbers are only fraction number. Only fraction numbers. So due to the fraction number is added in rational number, natural numbers as a combinations of integer number with fraction number, we can say. Consider the numbers 2 over 3. This point positive of the integer number, it is greater than 1 but less than 2. Between it is represented by between 1.5. This point is 1.5 between 1 and 2. So the belongs to interval between 2 and 1 and 2 shown in the figure 1.8. 2 over 3 is not natural number. This number is not natural number. It is rational number. This fraction number, what we call is rational number. Any number that can be written in the form of a over b, where a and b are integer number. This one is other integer, this one is other integers, and b is different from 0. 0 is whole number called rational number. We call generally rational number. The series of rational number is denoted by q, such that set of a over b, which means that a, b is the set of integer number and b is different from 0. A and b are integer, maybe positive integer or negative integer, except b is 0. If a is equal to 0, we call no matter. It is rational number, but b is always different from 0, which means that the denominators of the fraction is different from 0. If it is 0, undefined, any integer a can be written in the form of a over b, where b equal to 1. It follows that any integer is, in here any integer is rational number. Any integers are rational number when b is always 1. Always 1 means the right hand numbers are rational, are integer numbers, maybe positive or negative or 0. Some representing the rational number on number line. From this one is the red color shows that, or the red arrow shows that the positions of the rational number. If we remove these, the above sections, we got integer number, total integer number. But the point between one integer number, two integer number, in left side and right side is also zeros or negative integer and positive integer. We get different fraction numbers. Those fraction numbers are represented by rational numbers. So this generally, this graph or line number shows that rational number. Rational number is a combination of fraction numbers with integer number. So it shows that properties of rational number. Properties of rational number. Every rational number corresponds to the same unique point on number line. Rational number riin tokko bakka tokko qofa irratti number line kun lakkoofsa sarara lakkoofsa irratti represented ta'a. At only at unique points, not at different points. It is 1 1 or 1.5 1.5. If it is negative 1.5, we can say. So for today's section or for today's lesson, it is enough. For on part 2, we will see some definitions of the left one, and we will do those exercise detailedly, or the operations of rational numbers. Today we will talk about rational number, whole number, integer number, and natural numbers detailedly. On the second section, we will see the rational operations on the rational numbers. Operations on the rational numbers. If this channel is good for you, please subscribe and share for your friends. Har'a akkuma ilaalletti waa'ee integer numberii, whole numberii, lakkoofsa hundaa, rational numberii ilaallee jirra. Kutaa itti aanutti immoo operationoota akka jedhaman ida'uu hir'isuu, hiruu baay'isuu, rational numberii irratti akkamitti dhaan akkamitti hirra kan jedhu waliin ilaallaa jechuudha. Kun barnoota herregaa kutaa 7ffaati. Yoo isinitti tole subscribe and share gochuun walaa jajjabeessanu. Koomentii yoo jiraate yookaan exercise gilgalli isiniif hin galle pointii kamirratti yoo jiraate koomentii naaf godhaa, isiniif deebi'a. Assignment adda ta'e yookaan hojiiwwan garaagaraas yaaltanii isiniif koomentii naaf gochuu hin dagatina. If you have any questions based on this, You can put on the concessions. If you have homework, some exercise after you are tried, if it is difficult to you, comment on